Now we introduce two operations on vector fields. The first one is the divergence and the second operator is the curl. In both operations we used an operator called the gradient operator or del operator. Now in chapter 12 we talked about this gradient operator. It's a vector operator. We denote that operator using this nabla symbol. Now in three-dimensional space, this gradient operator has three components. The first one is partial over partial x, the second one is partial over partial y, and the third one is partial over partial z. And if you want the gradient operator in two-dimensional space, we take this third component equals to 0. Okay, and now we define the divergence of a vector field. First one, let's say if we have a vector field f with three components, f1, f2 and f3. Now in general, these component functions can be functions of x, y and z. So if we have a vector field f equals to this, then the divergence of f we denote the divergence of f using this symbol or grad dot f. This is the dot product. If f equals to this, then the divergence of f is the scalar given by the following equation. So we take the first component of the vector field and differentiate with respect to the x variable. We take the second component and differentiate with respect to the y variable. And we take the third component and differentiate with respect to the c variable. And finally we add these three parts together. This is the way we define the divergence of a vector field. Okay. As an example, let's say if my vector field f equals to x squared y comma xy cubed. So now we have a vector field in R2. Then divergence of f equals to partial over partial x of x squared y plus partial over partial y of xy cubed. And if you differentiate the first one with respect to the x variable, you should get 2xy plus, now we differentiate xy cubed with respect to the y variable, and we have x times 3y squared. And as you can see, this result is a scalar function. Let's consider another example. So now we are going to consider a vector field in R3. Let's say the first one is xc, the second one is xyz, then maybe the third one is, let's say, sine of xy. This is your f1, this is your second component, and this is the third component of the vector field. then divergence of f equals to partial over partial x of the first component, which is xe, plus partial over partial y of the second component xyc, plus partial over partial c of the third component, which equals to sine of xy. Now let's differentiate the first one with respect to the x variable. So now we can treat c variable as a constant. Therefore, the derivative of xc with respect to the x variable equals to c, plus, using the same argument, the derivative of xyc with respect to the y variable becomes xc, plus, now with respect to the c variable, this entire quantity is a constant because this one does not have the c variable, and if you differentiate a constant with respect to the c variable, you should get 0. And the divergence of f equals to c times xc. And this is the way we calculate the divergence of a vector field.